Hi, I am Fatin Nadira. Today, my partner Radin and I are going to present about the applications of the definite integral. By the end of our presentation, we would like for you to know what is integration, why and how do we use integration. Our talk is divided into 4 topics, which is area between two curves, volumes by this method, volumes by washer method, and volume by cylindrical shell method. What is integration? Integration is one of the two main operations of calculus. Given a function f of a real variable x and an interval of the real line, the definite integral. In maths, an integral assigns number to functions in a way that can describe displacement, area, volume, and other concepts that arise by combining data. Integrals are used to determine the probability of some random variable falling within a certain range. Integrals are also used for computing the area of a two-dimensional region that has a curved boundary. Integrals used to computing the volume of a three-dimensional object that has a curved boundary. Next, we move on to the problem statement and the solution. Firstly, the area between two curves. From the diagram, the shaded region R, which is bounded by the curve y equal to 4 minus x squared and y equal to x plus 2. We need to find the area of R. To solve the question, we need to substitute the two equations and find the interval which is x. We will get x equal to -2 and 1. Next, substitute the interval and equation into the formula. Expand, integrate and substitute the integration with interval. Finally, we will get the answer which is 4.5 units square. The next topic is volumes by this method. From the diagram, region W in the first quadrant, which is bounded by the curve x equal to y minus y cubed and the y-axis as shown in the diagram. By using this method, find the volume of the solid obtained by revolving the region W about the line x equal to 0. To solve the problem, we need to find the interval by substitute the equation of x equal to 0 and x equal to y minus y cubed. We will get y equal to 0, -1 and 1. And then, substitute the interval and equation into the formula. Expand and integrate y squared minus 2y to the power of 4 plus y to the power of 6. After that, substitute the interval. Lastly, we will get the answer which is 8 over 105 pi unit cube.
Hi, I am Radin. I'm going to continue to find the volume by using washer method. So the question is to calculate the volume A of solid generated by rotating the region between curves y equals to x over 2 and y equals to square root of x about the y-axis. So the y equals to x over 2 is the straight line and the y equals to square root of x is the curve. This is the formula used to find the volume by using washer method. The outer radius square is minus with the inner radius square. As stated in the question, it is rotated in the y-axis. So y equals to x over 2 will be x equals to 2y and y equals to square root of x will become x equals to y square. Next is to find the outer and the inner radius. The orange arrow is actually the outer radius, which is the straight line, and the red arrow is the inner radius, which is the curve. Next is to find the lower and the upper limit. We can find it by using simultaneous equation. So 2y equals to y square, and in the end we will find that y equals to 0 and y equals to 2. Substitute in the formula. So 2y square minus y square square. Expand, integrate, and solve it until you get the answer 64 pi over 15 unit cube. Next is to find the volume by cylindrical shell method. The question is to find the volume R of the solid obtained by rotating the region in the first quadrant bounded by y equals to 3x squared minus x cubed and y equals to 0 about the y-axis. So the y equation, y equals to 3x squared minus x cubed is actually a cubic graph. Second is to find the intercept. So we can find the intercept by using simultaneous equation. So this is the formula of volume by cylindrical shell method. It is 2 pi radius minus height. By the simultaneous equation, we can find the lower and the upper limit AB by x equals to 0 and x equals to 3. Third step is to draw a rectangle parallel to the x rotation. This rectangle is actually help us to find our radius and height. Next is to find the radius. We can attach an arrow or a line from the rectangle to the axis of rotation. So this is the radius. It is x is because the distance to the y-axis. Next is the height. The height is actually the height of the rectangle. It is distance up to the function of fx. That's why it is the curve. Height is the curve. Substitute in the formula. Expand, integrate, solve until we get the final answer 243 pi over 10 unit cube. So the conclusion is by using integral, a creative scientist, mathematician, or engineer can accomplish a great deal with numerical integration. Means that we can accomplish many things with using integration. That's all. Thank you.